today we are going to learn 8.7 constant coefficient equation with impulses. Okay, so what is impulse? So in physics and engineering, an impulse is the measure of force acting over a period of time. So, for example, we have a hitting a golf ball. So hit really hard at one moment, right? So from 0 to 150 miles per hour, then there's a spike, right? A hammer strike or kick a soccer ball, right? So etc. Okay, now let's get started with the function. So we have a function d sub t, right? Over t equal to the function has piecewise 1 over 2t. Then the t is between, so okay, a little bit confusing. Small t time t between negative t and positive t. Yeah. Okay. 0 beside everywhere, right? So everywhere. Where else? Okay. So let me draw this. So this is t, or we can say x because this is a function, right? Or this is y. And we make a t here. And we make a negative t here, right? Okay, I want to draw. So, if it's not between t, hold on 1 second. It's not between, where's the, yeah, here we go. If not between t here, negative t and positive t is 0, right? So I will draw that. That's the 0, right? Okay, then between negative t and positive t here, there is one over 2t for the height, right? So let me draw. So there will be 1 over 2t, okay? All right, then in that case, let me write down. So here, so this area doesn't look like a um, even, right? So we pretend even this one. So area equal to 1, right? Okay, let me show you why this is area equal to 1. So let's make integral negative infinity to positive infinity and the function d sub t over t dt, right? Okay, now the integral then base times width. Base times width, base times height, right? Width times length, whatever, right? So base times height. So we get, this will be 2t then? Yeah. And then height will be, this is the height. Yeah. 1 over 2t, right? Okay, so then there will be 2t times 1 over 2t, which is 1. Yeah, that's why area equal to 1, right? So that will be Dirac, not Dirac delta function. So let me write down for you. So we will have limit of t approach to 0. Okay, so let's say using t is more smaller. Okay, t approach to 0 is 0 is here, right? Okay, let's make a t, negative t here. Let's make a positive t here, getting smaller, right? Then let's make a 1/2 t is here. Yeah, That's also area equal to 1. Yeah. Let's make more smaller. So let's make more narrow, negative t and positive t. Then let's make 1/2. It's here, right? Also area equal to 1 because of this reason, right? All right. Let's make a more narrower. Yeah. And also area equal to 1, right? So eventually, even though we have this tiny much, tiny much, looks like 1/9, right? Still area equal to 1. Make sense? Okay, so let me write down. So there will be function d of t sub t of t equal to delta. We read delta, right? Greek letter, right? Delta is lowercase delta, lowercase in Greek alphabet, right? Okay, so of t. So we call this is Dirac delta function. I was thinking Dirac delta function. Okay, so let me writing one more thing. So altogether of this one, yeah. So there will be, we have a limit t approach to 0, then integral of negative infinity to positive infinity, d sub t over t, dt equal to 1, right? Okay, now we have Dirac delta function. Let me write down for you here, okay? Let me pause the video. Where is the pause? All right, so I wrote down here Dirac delta function here. So Dirac delta function, so the mathematician, I think British mathematician, so Dirac, and then he found out the delta function here. So look, I said earlier, right? So limit of when t is very t is approach to 0 means that the between t is very narrow, right? So eventually we will get the line as an area, right? And that is a delta of t, right? So Dirac delta function we created derive, right? Okay, then this Dirac delta function, when t is not 0, is 0. So everywhere is 0, right? Except 0, right? Except t equal to 0. So there's a open dot, right? When t equal to 0, so it's 0, right? And when t is 0, it goes to infinity, right? So it goes to infinity. That means it spikes, right? So goes to infinity. Make sense? So impulse, like a spike, one spot, one moment, right? Yeah. Clear? Okay. So this section is about the impulse with the Dirac delta function. All right? Okay. Now, some little note here. So delta function, Dirac delta function is not a function. What's going on? So it's not like f of t or f of x or g of y like that. It's not the function, right? This is a distribution, generalized function we called, yeah? generalized function or distribution. So if you took the statistic, there's normal distribution, right? But it's a graph, normal distribution, like a bell shape like that, right? And there is a t distribution more higher, yeah? So Dirac delta function also distribution or generalized function. Make sense? It's not the just regular function. Okay, now why this is not a function? Because normally function has the height, yeah, like a graph height, right? But it's infinite height and zero width, yeah? That's why it's not a function, okay? All right, now we have a unit step function. So this is we call the unit step function, right? So if we have an integral of negative infinity to t, then delta t of t minus 8, right? So normally we have a delta of t, right? But then here, minus 8, that means shift to the right means shift to right a unit, right? Yeah. Okay. And then when t is less than 0, is 0. Yeah. And t is greater than a, it's 1. Yeah. So in that case, switch on there, spike on a, right? So if we describe with Dirac delta function, then before strike and on strike, after strike, right? So let me write down. This is a before strike, spike. Yeah, strike, spike, same, similar spikes. And this is after spikes. So if we want to know about t equal to a, that's on spikes. Yeah, makes sense? Okay, this is a unit step function. So switch on, right? We have that. All right, so they say that the step function is the integral of the delta function. That means integral of the delta function is the step function, right? And if we have integral, then there is a derivative, right? So the delta function is the derivative of a step function, right? So if we derivative, then we get the Dirac delta function. Make sense to you? Okay. Now, we have a theorem. So the Laplace transforms, yeah? We have a shift of delta function. So Laplace of delta t minus a, then we get e to the minus as. So we are using this a into here, yeah? Okay, now f of t is a function on continuous open interval, right? And containing a, then Laplace of f of t, delta t minus a. So look, we have this one earlier, Laplace of that, then we get e to the negative as. Then Laplace of f of t, what we get f of a. Same a here. All right? Okay, let us do example. All right? So we have find the Laplace transform y over s of, so we have delta t minus 7. Okay, so a equal to 7 then, right? Because this is a form. So we take the Laplace of delta t minus 7. So a equal to 7, so we can just simply write e to the negative 7s. Yeah. Okay, let me put the S like here because I don't want to get confused with the 5. Yeah. All right, second one. So we have delta t minus 2. So a equal to 2. So we can express e to the negative 2s. Then t to the fourth power, that will be f of t, right? So f of t, which is f of a, right? Okay, so let me write down everything together. So we have e to the negative 2s and f of a, which is 2, right? Yeah, a equal to 2. All right, so a equal to 2 means we put on the 2 into the t function. So there will be e to the negative 2s and then 2 to the fourth power and 2 to the fourth power. Yeah. Okay, then 2 to the fourth power, what do you get? 16? Okay, good. So we have 16 e to the negative 2s. Make sense? Okay. All right. So let us do this question continually. So am I recording? Yes. All right. So let us solve. We have an initial problem there, right? Okay. So we want to answer y over t with two box. One is t is less than 6. One is oh, there's equal sign. Yeah. They're combining, huh? Because we said earlier, before spikes, after spikes, on spikes, right? So on spikes and after spikes. Okay, so let us do this one. So I brought up this formula because we will take the Laplace transform everywhere, right? So let us do that. So Laplace and take the Laplace. So y second prime plus 25y equal to Laplace of delta t minus 6. Yeah. Okay, now Laplace of y second prime plus 25 Laplace of y equal to Laplace of that a equal to in that case is 6. So we have e to the negative 6s. Yeah, make sense? All right, so then what is Laplace of y second prime? So we change it to rewrite everything. So let me just copy. Okay, so then plus 25. Laplace of y, we had experienced. So we using this one as y over s, right? Okay, so y over s equal to e to the negative 6x. Yeah, all right. Then initial, we apply initial value problem. So y over 0, y prime over 0 is 0. So very easy. So this is 0 and this is 0, right? Okay, then we have s squared Laplace of y, which is y over s, yeah, plus 25. Let me change it, yeah. So y over s plus y over s equal to e to the negative 6s. Yeah. All right, so solve for y over s, right? Okay, so y over s. And we have s squared plus 25 equal to e to the negative 6s. 6s, right? Yeah. All right, then y over s equal to e to the negative 6s over s squared plus 25, right? Okay, now we take the inverse of that. So inverse of everything inside. Okay, so let's talk. In that case, I brought up sine omega t, right? Okay, so we have to have omega too. So we had experienced this one, right? So omega in that case, let me write down inverse of 1 over s square plus 25 first, then inverse of and e to the negative 6s. Yeah. Okay, let me separate. All right. So in that case, I'm sorry, omega equal to 2. I'm sorry, omega equal to 5. I need to sleep. Omega equal to 5. Yeah. And since we don't have a 5 on numerator, right? So let's make 5 and 1 over 5, right? Okay. So that's we taking care of, right? All right. So that will be 1 over 5, then sine omega t. Yeah. I'm sorry, omega is the 5. Yeah, sorry about that. 5t. Okay, what about this one? This one, let's talk about that. We will talk about, it was from delta t minus 6. Yeah, that's why a equal to 6, right? Okay, so what we are doing in the case, so if we have, maybe writing out, no space, note. So inverse of Laplace transform of f of s and e to the negative as. Okay, this one we will use that f of t minus a and u of t minus a, right? Okay, a in the case 6, right? So a in the case is 6. So this one, f of t minus a, we will use t minus a. T minus a. And u of t minus a. Yeah. So how do we write? So there will be t minus 6. And we will writing 1 over 5 and u of t minus 6 and sine 5 t minus 6. Yeah. Make sense? Okay. So we using t minus 6 instead of just t. Yeah. So we change everything. Clear. Okay. Okay, I think this is okay. I don't need it. We don't need this one. No. F of t minus a, u of t minus a is enough. All right. Let's talk about this one. We have a definition, and we have initial value, second order problem, right? And we have Dirac delta function right side and initial value problem, right? Okay, now we have the form ut minus t naught, which is a, same as earlier, right? And omega, we have omega. So how do you find omega? Then inverse of 1 over as square plus bs plus c. So abc from here, abc, yeah? That's the definition. Okay. Then we have a impulse response. Yeah, so omega is called impulse response. So we have three different answer, right? So we had this one earlier, over damped, critically damped, under damped. Yeah. Okay. So how do you find out over damped, critically damped, under damped is from 6.2 recall spring problems number 2. So we have a damping problem, right? Under critical over. So depends on C. So C from the middle damping force coefficient. All right. And then C is less than square root of 4a mk. So mk from first term, third term, right? So C is less than, C is same as, C is greater than. So under critical over in that case. All right. Okay, then let us do let me do same problem here. Yeah. So I want to show you how quickly we can find by using the definition from the textbook. All right. Oh, I have not answer. The answer is, so the answer is 0 and 105. Let me write down for you. So there is no space, huh? Okay. So I have to conclude this answer, right? So the answer will be one is 0. Copy. So the solution, right? So one is 0. Solution will be 0, and the other one is 105 sine 5 t minus 6. That's the answer. All right? Yeah. We not include, note, we not include the u t minus 6 because this is the one. All right? Okay. Let's do, let me copy, and then I'm gonna show you with that definition. Copy. So other method, right? All right. So the definition say that omega, right? So omega is here. Okay. This is from. All right, so omega equal to inverse of 1 over A. Look, A is the 1, S squared, right? Plus V. Look, we don't have V there because there's no Y prime, right? So it's 0 plus C, which is 25, right? Okay, that will be inverse of Laplace of 1 over S squared plus 25. Yeah. Okay, then boom, done, right? So we knew that sine omega t, right? So omega equal to 5. So omega 5, 1 over 5. So that will be 1 over 5 sine omega. Now, omega equal to 5t. Yeah. But then we don't use t, right? So t minus t naught, that's why they don't use a. T naught, yeah? So will you use, so the right side has delta t minus 6. We are using that, right? So t minus 6. And then they say that u of t minus t naught, right? So we're using u of t minus 6 as well. Make sense? This is very easy, right? Yeah, shortcut. What do you think? Then answer will be, answer will be 0. And then 1 over 5 sine 5 t minus 6. Oh, no space. Okay. All right. Okay, so I forgot to tell you another method here too. So, method, let me see, other methods. So number 1 and number 2. All right, so let's talk about the omega here, impulse response. So underdamped. All right, so let's talk about the underdamped. So from the spring problem, so if we have a damping is C is less than square root of 4 mk, right? So in that case, let me write down, copy. So paste underdamped. Okay, so we had, in that case, C equal to 25, I think, less than square root of 4 times the first one. Oh, that's not the one. Hold on 1 second. Okay, so I brought up the equation here. So C is in the middle, so we don't have a middle, so it's 0, right? So 0. And then for M equal to 1, and then K equal to 25, right? So absolutely. 0 is less than, it's 100, which is 10, right? Yeah. Okay, so it's under damped. Then we are using that equation, right? So omega equal to that. Copy. All right. So A in the case, we are using A from here, right? So A in the case is A1. So A in the case 1 and omega omega. So we are using omega equal to 5 inside the omega, right? Yeah. Lambda. How do you find the lambda, right? So lambda equal to, okay, so basically we have, note, s squared equal to s squared plus 25 equal to 0, right? S squared equal to negative 25, right? So s equal to plus minus, how about 5i, right? Yeah. Okay. So we have the form. So there will be lambda plus minus omega, right? I, right? So in that case, lambda equal to 0 and omega equal to, we are using 5, right? Make sense? All right, so we will get 1 over A equal to 1, omega equal to 5, and e to the lambda equal to 0, t sine omega, which is 5t, right? Yeah, this is how we get that too. Make sense to you? Sine 5t. And then we change that later. 105 sine 5 t minus 6. And then we are using u t minus 6. Yeah? Okay, now let us do this example. So we have an initial value problem. This will be last one, and then this is very complicated. A lot of work there. Okay, let us do impulse one first because we just learned that, how to make a shortcut, right? Okay, so we have the second term of right side 2 delta t minus 1. So that means shift 1, right? Okay. So we can use that. That's a 2e to the negative s. Yeah. All right. But then let's using that for 2 lambda t minus 1. Yeah. Okay. So we have y double prime plus 6y prime plus 5y. We can express as s squared plus 6s plus 5 equal to 0, right? Then factoring out plus 5 plus 1 first. 1 and s plus 5 equal to 0. So s equal to negative 1, s equal to negative 5, right? Okay, in that case, we have two real numbers, right? So let's take a look here. If we have two real numbers, that means this one over, yeah? Two real numbers. Critical is one exact, one solution, real solution. Under is the complex solution there. Two complex numbers, yeah? So this is too complex. One exact, one solution. And this one, two real solutions, right? Real number solutions, yeah? Okay, so it's over damping, then we are using this solution, yeah? Omega equal to that. Copy? So let's say that this is R sub 1 and this is R sub 2, yeah? Okay, A in the case, this is A, so A equal to 1, right? Yeah. Sorry, too many A there. Yeah. So this A is this A, right? Sorry. Okay. Yeah. T minus A there. And then coefficient of A, yeah? Make sense? So this A we talk about. Yeah. All right. So let's just using that. E to the R sub 2, which is negative 5t, minus E sub R sub 1, so negative 1t, over A R sub 2, which is negative 5, minus R sub 1, which is negative 1, which is e to the negative 5t minus e to the negative t over, it's a positive negative 4a, a equal to 1, right? So a equal to 1. Negative 4? We get positive or negative? Oh, r sub 1 equal to negative 1, right? Yeah, I did that, negative 1. So what did I make a mistake? Negative r sub 2, right? Negative 5 and negative, and this is the positives, yeah? So it's a negative 4. Okay, so let's leave for now. Okay, then we will change that later. So this will be changed that we have, look, we have 2 lambda t minus 1, right? So 2 lambda t minus 1. So we have a shifting to the 1. So instead of writing t, we're using t minus 1. Yeah? We just learned that, right? Okay, so we will have that. This one we can express as a u step function. So u t minus 1. So 2 u t minus 1. So altogether we will have 2 so we will have 2 u t minus 1, and we will get 104 negative. So let me think about that. Let me checking that. And e to the, we will use minus 5t minus 1 and minus e to the negative t and minus 1, right? Yeah. Okay. All right. So that will be, we simplify. So we get 1 over 2. So ut minus 1. So we have e to the negative 5, t minus 1, minus e to the negative t minus 1. Yeah. That's for impulse part. Okay, now we have to work everything. A lot of work. Okay, so I'm gonna do everything. I'm gonna show you how to do everything together. But since we found impulse this part, so I'm gonna skip later on. All right? Okay, let's do it. Let me copy. Oh, that one I have to check. Okay, hold on 1 second. Let me first, and then let me check that positive for first. Let me make a clarify this one first. Okay? Then we move on to everything together. Yeah, I don't see that I make a mistake, but I make a mistake here. So 1/2. I did not write down 1/2 there, right? So yeah. But then -4 there. Yeah. So I did not make a mistake. So okay. So -4. Okay. Let's do it. Let me copy everything. Copy. And that. This will be a lot of algebraic work. Okay, now. Okay. We do that like earlier, right? So we take the Laplace transform every term. So we will get Laplace. So the left hand side, copy, and right hand side, copy. Okay. All right. So combining, not combining, so split every term by second prime plus Laplace of, let's make a 6 y prime plus 5 Laplace of y equal to Laplace 3 e to the negative 2t. Yeah, curly bracket, not curly bracket, just whatever, t minus 1. Okay, so we need the Laplace of a second prime. So like orange color earlier, right? Sorry. Oh, too many pages over. Okay, I just did not want to write down this way. Okay. All right, let's go back. Okay, so that is that, right? Let me write down like that. How about that, right? And Laplace of y prime will be, let me write down. So there will be plus 6 and s Laplace of y minus y of 0 power, right? And plus 5y Laplace of y, right? Laplace of y. Okay. Equal to 3. Let me writing out everything, yeah? And then we convert everything later. Laplace t minus 1. Yeah. Okay, so we knew that Laplace of y equal to y over s, right? And then solve for y over s later, right? Okay, so we have s squared and y over s minus y prime over 0, which is 2 given, right? So it's 2 minus s y over 0, which is negative 3, plus 6 s y over s minus y over 0 equal to negative 3, right? And plus 5, Laplace of y is y over s, y over s equal to 3. Okay, how do we change it to convert to Laplace to e to the negative 2t? So do we have, I have? No, I don't have. Okay, so Laplace of e, okay, right here. E to the a to the t power. So maybe I'm gonna write down here. Yeah. Okay, then 1 over s minus 8, right? So there will be 1 over s minus a. A in the case is 2t, right? So a equal to negative 2, actually, negative 2t. So negative 2. All right, and plus 2, a equal to 1 in the case. So we write e to the negative a. So negative s. Yeah, because negative as, a equal to 1 time s. How about that? 1 time s for you. Yeah. Okay, now rewrite everything. S square y over s and minus 2 plus 3s plus 6s y over s plus minus 18 plus 5y over s and equal to 1 over s plus 2 plus e to the 2 e to the negative s. Yeah, make one line. Please correct me if I make a mistake. I cannot see. You cannot see. I cannot see. We cannot see. All right. So negative, negative. Hold on 1 second. Negative, negative is positive. Why this is yeah. Okay. I made a mistake, huh? Okay, so this is negative 2 And we have positive 3s and positive 6s y over s. And in that case, it's a positive 18. Why this is positive 18? We have a positive 6. And we have a y over 0 equal to negative, negative. I see. Negative, negative is positive. Yeah? It's negative, but then this is also negative 3, so it's a positive. Make sense to you? Yeah. So let me write down positive. And this will be positive then, yeah? Okay. So positive 18 minus 2, which is negative 16, right? And that's it. Okay, then let us do combining negative 16 and then all the factoring out y over s so that we can solve for y over s, yeah? So y over s s squared um, plus 6s and plus 5, yeah? Okay. And we have a positive 16 plus 3s equal to 1 over s plus 2 plus e 2 to the e to the negative s, yeah? Okay, so everything move other side and then divide by this, yeah? Okay, so there will be solve for y over s. Okay, so there will be y over s equal to negative 16, negative 3s, and we get, ooh, missing something too. Okay, missing 3. Yeah, 3 there. Sorry about that. So missing 3 there. 3. So 3, 3, right? And plus 3 over s plus 2 plus 2e to the negative s, yeah? Okay. Now, divide by, everything divide by s squared plus 6s plus 5. Yeah. Okay. Now, all right. So there will be we noticed that this is same as we factor out earlier, s plus 1, s plus 5, right? Okay, so I want to arrange it this way, okay? So y over s equal to 3 over this one first, yeah, s plus 2, and then s plus 1, then s plus 5, yeah? And that will be negative 3s minus 16 over, yeah, then plus. And s plus 1, s plus 5, and then last term 2e to the negative s over s plus 1, s plus 5, right? So this one we did that, right? We did. Yeah. So now we are working on two terms. So I make a one term for this one so that we can finish quickly. Yeah, we can process quickly. Okay, make a two term. If we do one by one, then more takes time, right? Okay. All right. So let us do that. Common partial decomposition, right? So for the first term. Okay. Then we're done for second term. Oh no, what I'm doing. Hold on 1 second, sorry. Yeah. For the first term, so 3 over s plus 2, s plus 1, s plus 5. Okay, partial decomposition, right? Okay, so we get a over s plus 2 plus b over s plus 1. I am recording, right? Okay. And plus c s plus 5. Common denominator. So s plus 2, s plus 5, 1, s plus 5, a s plus 1, s plus 5, plus b s plus 2, s plus 5, plus c s plus 2, s plus 1. Yeah? Okay. Oh, so let's make zeros, right? So when s equal to -1, so we have 3 equal to and 0 plus b, -1 plus 2, -1 plus 5 plus 0 equal to +1 and +4. So it's a 4, 4b. Okay, then b equal to 4, 3 over 4. Yeah. Okay, now when s equal to -5, 3 equal to 0 plus 0 plus c -5 plus 2 -5 plus 1. Yeah. So this is -3, this is -4, so 12. So that will be 3 equal to 12c, which is 1/4. Okay, now when s equal to -2, so 3 equal to a s, no, -2 plus 1, -2 plus 5, and then rest is 0, right? So -1, +3 is 3 equal to -3, a equal to -1, right? Okay, now we have ABC. Copy that. So that will be pink. -1 over s plus 2. B positive 304 over S plus 1. C positive 104 over S plus 5. Yeah. Okay, second term, then we're done. Yeah. Okay, now for a second term, copy. Second term. Partial decomposition, right? Okay. So S plus 1, S plus 5, A over S plus 1 plus B over S plus 5. Yeah. Okay, so there will be common denominator. S plus 1, S plus 5, A, S plus 5, B, S plus 1. Okay, now, so we distribute. So we get AS plus 5A, oh, plus BS plus B, right? Over S plus 1, S plus 5. Okay, so we have A plus B as S term, which is negative 3S. We have 5A plus B as constant term, which is negative 16, right? Okay, so we just ignore S with S, right? So let's make that subtract. Then B term is gone, right? So then we get negative 4A equal to negative is the positive 16. So 3? I'm sorry, 13? So A equal to negative 13 over 4. Yeah. What about the B? So A plus B equal to negative 13. So negative 13 over 4 plus B equal to negative 3. So B equal to positive 13 over 4 minus 3 equal to, so 4 over 4. So we get 12, 104. Yeah. Okay. So all together we have copy and we will get A negative 13 over 4 over S plus 1 plus B 104 over S plus 5, right? Okay. So we did that last term, so all together, yeah. So we take the Laplace transform. So all together. All right, so inverse of Laplace transform of the first term, pink, copy, and second term, pink, and then the last term we had already, so we don't need that. So plus. Okay, so looking at that, the table, yeah. Okay, what do you get? So we had e to the at power earlier, right? So still, do I still? No, I don't have that. Okay. Okay, so we had this one. Okay, so the first term, we have a equal to -2, yeah? We have a -2. And second term, we have a equal to -1. Third term, we have a equal to -5. And fourth term, we have a equal to -1 and a equal to -5, right? Okay, now we have let's combining because looks like we have many term, right? So let's make a combining like term first before we determine. All right, so we have this term, we have this term is the same, right? Okay, we combining, then we get -10/4. So that will be -10/4, which is -5/2. Yeah. Okay. How about we combining this and this? 104, 104, which is 204, which is 1/2. Yeah. Okay, then let's do that one more time. Inverse of Laplace -1/s plus 2 and plus -5/2 over s plus 1 and plus 1/2 over s plus 5. Yeah. Okay, now that will be negative e to the a -2t. Yeah. All right. And there will be -5/2 e to the -1t and positive 1/2 e to the -5t. Yeah. Okay. Then now we have impulse part. Impulse part. We did in the beginning. Don't forget, right? So we have this one, right? Yeah. Okay. Copy. and the last part of this one. Yeah, it's okay with you. So interpretation, they have when t equal to 1, that's the impulse heat, not the heat. After t equal to 1, system continue to move with this, delay the response. Before t equal to 1, the step function u of t minus 1 equal to 0. Yeah. All right. Okay. Thank you for watching. I will see you in the next video. Bye.